The combined gas law is P1 V1 divided by T1 equals P2 times V2 divided by T2. And this can be used for Charles's law, Boyle's law, or it could be used for combined gas law problems. You must keep in mind that the temperatures have to be in Kelvin, which means if they're in Celsius, you'll have to add 273 to them to get them in Kelvin, and it won't work if they're not in Kelvin. It doesn't matter what pressure units are as long as the units for P1 and P2 are the same. And it doesn't matter what the volume units are, if they're in milliliters or liters, as long as the V1 and V2 units are the same. So for example, here's a problem. It tells me that we have a 425 milliliter container. It's at 22 degrees Celsius and 760 millimeters of pressure. And they want to know when the temperature is changed to 30 and the pressure is changed to 360, what is going to be the new volume. So here's our combined gas law. So I plugged in the 760 and the 425, and on my other side my pressure was 360 and I didn't know my V. Then I took the 22 degrees Celsius and added the 273 to get 295. Then I took the 30 degrees Celsius and added 273 to get 303. So I have all of my numbers in there. Now to get V all by itself, I'm going to want to cross multiply. So I have 760 times 425 times 303. And then I'm going to divide that by 360 times 295. And when I do that, I should get an answer of 921 milliliters. So that will be the new volume. And as I mentioned, you could use this for Charles's law or Boyle's law. For example, if your temperatures are the same, then you would simply leave out the temperatures and you would be left with P1 times V1 equals P2 times V2. Or let's say that your pressures were the same. Then you would just use V1 over T1 equals V2 over T2. So this same combined gas law can be used for a lot of different problems, and if one of the variables stays the same, you just have to leave it out. So that should explain the combined gas law.